Hello everyone, today is December 12th and I'm excited to present a new problem on LeetCode as part of our Coding Advent Calendar. Please note that while this problem is marked as easy, it is actually quite challenging and requires careful thoughts. There are multiple ways to solve it, and some of these ways are more efficient than others. We are going to use dynamic programming and Fibonacci sequence. Let's begin. Here is today's problem. Climbing stairs. You're climbing a staircase. It takes n steps to reach the top. Each time you can enter, you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So for example, n equal to 2, and we need to return 2 because we can do it 2 ways. 1 step plus 1 step, or 2 steps, 2 ways. N equal to 3. Output is 3. 1 step plus 1 step plus 1 step, 1 step plus 2 steps, 2 steps plus 1 step, 3 distinct ways. We have n at the entry point, at the input data, and we need to return the number of distinct ways. Okay, let's do some more observations here. So 1. How many different ways there are to reach the first step? It is 1. It is 1 step, and we have 1 here, right? For 2, there are 2 ways, 1 plus 1 and 2, like 2 ways. 3, 1 plus 1 plus 1, 1 plus 2, and 2 plus 1, right? 3 ways. Let's do some more observations. 4, 1 plus 1 plus 1 plus 1, 1 plus 2 plus 1, 2 plus 1 plus 1, 1 plus 1 plus 2, 2 plus 2. Okay, 1, 2, 3, 4, 5. 5. And let's do one more. 1 plus 1 plus 1 plus 1 plus 1, 1 plus 2 plus 1 plus 1, 2 plus 1 plus 1 plus 1, 1 plus 1 plus 1, 2 plus 1, and 2 plus 2 plus 1, 1 plus 1 plus 1 plus 2, and 1 plus 2 plus 2, 2 plus 1 plus 2. Okay, all distinct ways. To here, to here, to here. Okay. Yes. 1, 2, 3, 4, 5, 6, 7, 8. 8 ways. 8. And how to calculate how many ways, how many distinct ways there are to reach the 6th stair? Let's take a close look at this sequence. Do you see the pattern here? So look at this one and this one. They are different in last symbol, last one, right? Okay, what about this? What about this? What about this? What about this? See? And one more. Look. Okay, see the magic of numbers. Okay, so I say that the number of distinct ways to get to the sixth stage is sum of number of ways to reach the previous and the one before previous. So here 8 equal to 3 plus 5. Here 5 equal to 3 plus 2. Here 3 is equal to 2 plus 1. Okay? So f function of 6 equal to function of 5 plus function of 4, and more precisely f of n equal to f n minus 1 plus n plus f n minus 2. And this formula we are going to use here when we calculate our result. Let's do some helper function. And I will do it like this. I will pass this integer parameter here, and I will also do a little trick which is commonly used for dynamic programming. I will use something like memorization. I will show you why in a minute. So let's do it like this. If we need to have a few stoppers. If n equal to 0, we can actually get here and if n equal to 0, then we reached 0 backward from some stage, and we need to return 1, or vice versa. We from step 0 we can reach the next step, wherever it is in one way, right? Either if it's 1 or if it's 2. From 0 it's 1 step, and we need to return 1. If n equal to 1, we also need to return 1. Okay, what next? We need to calculate it for n minus 2 plus for n minus 1. Okay, and let's look at this DP. This DP is a helper array which should store a number of ways which required to get to some number of steps, some level, right? Because during our binary recursion here, we can execute this function with this argument many times because of the nature of our binary recursion. So what we're going to do here is to store this temporary result in this array, and we will return it after calculation. And if dp of n more than 0, so for this concrete n, this function is calculated already. We need to return dp of n. All we need to do here is to return this function. We need to pass n here, and we need to send a new empty array of size n plus 1. Why n plus 1? Because we will not store anything for position 0, and all values in our array are shifted to the right, because n is positive, it's 1 based, it's not 0 based, so we should use 1 based array or array of size n plus 1. And let's try it. As you can see, it works, this formula works, and let's submit it. Okay, it's done. And let's estimate the time complexity and memory complexity, memory consumption of this algorithm. So, because we use memorization, for each n, we don't have to do more than one calculation. In the end, our dp of n plus 1 will be full of values. That means for each value we will calculate it once, so the time complexity is big O of n. And also we use a recursion here, or even simpler, we use this array of size n plus 1, which leads for memory consumption big O of n. So in order to solve problem of size n, we need to have array of size n plus 1, so it's big O of n. I will show you another interesting sophisticated way to solve this problem. If you look closer at these results, 1, 2, 3, 5, 8, and so on, you will notice that this is a Fibonacci sequence. And having this in mind, we can use different solution. I have prepared it. I don't have time to, and you probably will not have time to watch the whole calculations, like how to solve this Fibonacci sequence problem. Here I will just enter result here, and without any recursion calls we can calculate this formula for n, and it should just work. Let's try. It works, let's submit it. Okay, you see, it's accepted. So our second solution also works. I offer you to read a bit more about what Fibonacci sequence is and how to calculate nth Fibonacci number. I hope you enjoyed today's video. Problems like this one demonstrate the full power of algorithms and the importance of understanding them. Please stay tuned for more challenges and solutions. I look forward to seeing you tomorrow.